Okay, here is the Leica microscope explanation of the functions and the inside the Leica software, and also we also explain some of the how to calculate surface measurements and volume measurements. So first we have a sample here, then we try to adjust the sample position. We increase the magnification of a sample to make it clearer, and then adjust the sample to the point where we want it to analyze. So this is me adjusting the sample, the position of my sample. Okay, so the first we have the intensity. Here it's to adjust the intensity of my sample, either make it so bright or make it a bit dim. And then we also have the exposure and the gain. We can adjust it in a way where we want it, in as much as a sample is visible and clearly to be observed. And then here this is adjusting the exposure to any point, increasing it or decreasing it. And it's better to just have a good okay, so here is the measuring tool. This is just the distance from here to here. We can see the result here. This is from 21.16 millimeter. Here is this, and this is the area. Oh, okay, this is the area. Okay, here is the zigzag, and then we have the custom. We have the begin position. So we set begin where we want our scan to begin. Okay, after finish setting begin, we also have the end position. This is the begin position. Here is the end position. So we set a position, and then we also change a number of steps. We reduce the number of steps. Here I choose step 40. If you want a very clear view or a high view of your image, it's better to increase the number of steps. So depending on how clear you want your sample to be, you set your number of steps. Here the step is 40. Then we have a scanning in progress here, so it's going to take about 20 seconds for our for our sample to finish scanning. So if we have chosen a number of steps of about 60 steps, it would have taken a very longer time for us to have to achieve a scanning this thing. Okay, our sample has finished scanning, and here is the 3D. So we click this to have the 3D measurement. Okay. Okay, so here to when we observe the 3D measurements, we use the medium objective lens, so we get this result. But if we want a better view of the 3D scan, it's better to use an objective lens of focal length 43.5. It will give us a more clearer view of our surface profiling and volume profiling. Here we've changed the objective lens to 43.5 focal length. So here is the zigzag. Then we'll have a click, move my sample to the top edge of my sample. Okay, and the first part we only use the z-stack, but for us to get a very clearer image of our 3D, is better for us to use both the two functions. So using this function, I don't know what it's called, then you move a sample to this other edge. So after observing the first edge, we also move our sample to the other edge. Then we set begin and end begin, just as we did the first time. So this is our z-stack set end begin.
It's okay.
Now we set end. Okay, and then we start the experiment. So we can see that the sample is being scanned right now. Okay, this is setting the scan again. Begins, set begin, and starts the experiment. So so the scan is in progress, so we have to wait for it to finish scanning. Then we click this button for 3D observation. Sorry, this. So here is our 3D image of our sample. This is the 3D image of our sample. Okay, so we have some measurement tool. Here we adjust the view angle or Z scaling. So we choose our measurement tool. We have the scale bar, the axis scaling, and the draw frame. So we click the 3 buttons. So you move your sample, you pick this, move your sample from here for us to observe the surface profile. So this is the distance from here to here. Here, the first one, we have a 41.97 millimeter. So these are the volume profiling and this, and then we click for also measure for the volume measurement. For the volume measurements, scale this. And here is the result of our volume measurement. To measure the particular volume at this area, we can just mark it, and then we see the results right here. Volume to be this. So here is a 3D image of both the surface profiling and the 3D volume measurement. Thank you.